All right, so 3-4, we talked about solving exponential and log equations. Obviously, this isn't all the different types, but this is 3 of the examples that we talked about yesterday. The first is exponential. So if it's exponential and I can't change the base on both sides, which obviously you can't do with e, right? What do you have to do? I'm going to have to ln both sides once I get e on the side by itself, right? So the first thing I want to do is get e on the side by itself. So the first step there would be what? Add the 3. And then divide by 2. And I get e to the x equals 13 over 2. So I can't ln both sides until that e is completely on the side by itself, or whatever the base is on the side by itself, okay? Now I can ln both sides of this equation. The ln of e to the x just becomes x equals ln of 13 over 2. So if it's on the portion of your test that does not have a calculator, then you would leave it as 13 over 2. And then obviously if it is on the portion that you have the calculator, you would find ln of 13 divided by 2, which is 1.872. I think I said it yesterday, but I'll reiterate it, that you can use either scientific or graphing calculator because I separated off the graphing. So whatever you're comfortable with, you can use that because I separated it off. Just make sure you're practicing whichever one you're going to be using, and obviously don't forget it too. So. All right, 2 says log of 4x equals 2. So this is in a case where I have just a single log on one side, right? What can I do with this? Good. Make it exponential. So what's the base on the log if it's not already written there? 10. So then 10 gets raised to the second power, drops off, and I get 4x. 10 to the second, which is 100, equals 4x. Divide both sides by 4. And x equals 25. That did not require a calculator. Okay. Obviously, it could be on the portion that doesn't require a calculator. And what do you have to do with the ones that start with logs? You have to check these answers. So this is one you have to check. I have to plug that back in and just make sure that when I simplify what's next to the log, it's not 0 or negative, okay? Remember, you could have extraneous roots, so you want to always check it. That means like if you get your test on Tuesday and you want to go through it and start like starring the ones that have logs at the beginning so that you remember to check them, or ln's, do it. Whatever's going to remind you to check the answers on those. The other ones you're checking just to see if you're right, but those you're checking to see if there's an extraneous root, so you have to do it. All right, 3, this is a case where I have multiple logs on one side of the equation. If I had multiple logs or multiple ln's, what do I have to do?
Combine, condense.
Good, condense them. So because this is addition, when I condense it becomes what? Multiplication. So this would be log base 3 of 5 times x plus 2 equals log base 3 of x plus 6. Now I've got options. I can get everything to one side, and then my exponent on the 3, when I convert it to exponential, would be 0, and I can work it through and solve it. But probably easier is if you get something like this where you've got one log with the same base on either side. You're using your one-to-one property to say I can ignore this, and I can just set these two things equal to each other. So 5x plus 10 would equal x plus 6. Subtract the x. 4x equals, subtract the 4. Subtract the 6, doing the math in my head ahead of time, and you get 4. Oh, wait, here. Subtract that 10. Subtracting the x, 4x, right? And then subtracting the 10. And I get negative 4, and then divide by 4. And I get x equals negative 1. Now, I don't rule it out because it's negative. What I have to do is check to see if when I take this and I plug it back in, do I get an answer next to the log that's negative or 0? So if I plug it in here, negative 1 plus 2 is still positive. That's a positive 1. Plug it in here, negative 1 plus 6 is 5. That's still positive, which means I can keep that negative 1 as my answer. Questions on any of those? All right, then homework questions. So this is 6. 6 said solve the log equation and then round your answer to 3 decimal places. So this is a case in which I have one log is an ln. Ln is a log. So I have one log on the side of the equation by itself. I've got to convert this into exponential. So the first thing I'm going to do is rewrite ln as log base e of 8x plus 4 equals 3. Then I'm going to convert it into exponentials. So e comes over, picks up the 3, drops off, leaving 8x plus 4. Now without a calculator, I can keep going. I could subtract the 4. So I would do e to the third minus 4 equals 8x. And then divide by 8. And I get x equals e to the third minus 4 over 8. Without a calculator, that's as far as you go. But with a calculator, you keep going. So I would do e to the third, which is 20.0855, subtract 4 from it, and then divide it by 8. And I get 2.0106, which becomes 2.011. This one started with an ln, so I would want to check to make sure that if I plug that back in, I don't rule it out. 8 times a positive 2 plus 4 is definitely going to be positive, so it's fine. Good on that one. Okay, 11 said solve the log equation algebraically, round to 3 decimal places, verify your answer using a graphing utility, enter your answers as comma separated list. If there's no solution, enter no solution. All right, so I'm going to condense because I've got 2 logs on one side over here. I got to condense that. That becomes log base 3 of x times x minus 8 equals 2. Then 3 goes over, picks up the 2. 3 squared equals x times x minus 8. 9 equals x squared minus 8x. As soon as you see the squared and the non-squared, you should know you're going to factor. I'm going to get everything to one side. And then factors of negative 9 that sum to negative 8 are negative 9, positive 1. Set them each equal to 0, and I get x equals 9 and x equals negative 1. So without checking them, you would plug them, you would keep both those answers, but this is a case in where you've got to check them. So if I plug a 9 in here or here, it's fine. But if I plug a negative 1 in here, it doesn't work. So I rule out the negative 1 and I keep just the 9. And then the last one, again, solve algebraically, approximate your result to 3 decimal places. So this time I've got 2 logs on one side because ln is a log. I'm going to condense this into ln x plus 5 over x minus 4. So it was subtraction, which means division. And then I've got this 1 ln, so the same log base e on either side of the equal sign, which means I can ignore those and use the one-to-one property to set these two equal to each other. X plus 5 over x minus 4 equals x. Then I would multiply both sides by x minus 4. I get x plus 5 equals x times x minus 4. X plus 5 equals x squared minus 4x. Subtract the x and the 5. And I get 0 equals x squared minus 5x minus 5. Now there are no factors of 5 that sum to negative 5, or negative 5 that sum to negative 5, which means you have to do the quadratic. A would be 1, B would be negative 5, and C would be negative 5. So negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. And I get 5 plus and minus the square root of 25 plus 20 over 2. 5 plus and minus the square root of 45 over 2. You can keep going and simplifying that, or you know you need to get the answer at some point on your calculator, so you could do it from there. I would do 5 plus the square root of 45 divided by 2. Which is 5.854. And then I would do 5 minus the square root of 45 over 2. Which is negative 0.854. And again, those would be my answers, except you have to check them in your original equation. If I plug in the positive 5 here, here, and here, I'm fine. But if I plug in a negative 0.8, this one is fine. This one and this one would both give me the log of a negative number. So you can't keep that one. You would just keep the first 5.854. Any other questions from the homework? All right, let's talk test review. So again, your test is Tuesday. It's covering 3.1 to 3.4. This is the first test of the quarter. You must have a calculator. You can use a scientific or a graphing. That's up to you. Use whatever you're the most comfortable with. Good morning. All right, so 3.1 was the introduction into exponentials. So you can be simplifying exponentials. You can be graphing. We did a word problem on here where we talked about like an exponential decay or growth. Okay, you'll see that in your review. And then the interest problems are on here as well. So remember with graphs, this could be like a 3 to the x, or this could be like an e to the x, because those are both exponential. With the graph of exponential, if it's positive, it's increasing as it moves from left to right. It has a horizontal asymptote, which is the y equals whatever the vertical shift is. It has a domain of negative infinity to positive infinity. And it has a range, that is the vertical shift, to positive infinity. And it has a y-intercept, which you would get from your t-chart because you'll be plugging in 0 for x. Again, you'll see word problems in your review, okay, for examples, but they somehow have some sort of exponential where you could plug in or figure out information based on it. And then the interest problems, you had two different kinds. One where it's a number of times a year. And that is A equals P times 1 plus R over N to the NT. Or continuous, which is PERT. Make sure you know how to type that stuff into your calculator, because that's what got some of you on the quiz. Questions at 3.1. So part of it calculator, part of it not calculator. Obviously the graphs of the exponential functions, not calculator.
Wait, for the range, how do you find the x again?
It's based on the vertical shift.
Oh.
So if it's up 2, then it starts at 2. 2 to positive infinity.
Oh.
Right? So if it said like 3 to the x plus 2, that's 2 to positive infinity. It's going to be the same as your horizontal asymptote. If it said 3 to the x minus 2, now it's negative 2 to positive infinity. 3 to the x. Oh, NT. And these I won't tell you, so you're going to remember that this is money, which means you're going to round to the 100th or the nearest cent. Then came logs. So 3.2 was logs. Obviously, you were simplifying logs. You want to know things like log base 3 of 1 would be what? 0. Anything in which the big number is 1 is 0. Log base 3 of 3 would be what? 1. Okay, if the small number and the base are the same. You want to know that ln of e to the third, maybe, would be 3. The ln of 3 cancels out, leaving you with just your exponent. And something like ln, or log 3 of 3 to the 8th, let's say, is the same thing as like saying the same ln of e and e, right? Because those are the same. This would be 8. So you've got all those little properties where you're simplifying, and that's like mental math. You also had e to the ln of 4, let's say. If the base on the exponential is the same as the exponent's base, then this would also cancel, give you just 4. Or if you had, let's say, 3 log base 3 of 8, that is also 8, because the exponential base and the base on the log are the same. And then we graphed logs. So graphing of logs this time, they look like this, okay? Now they have a vertical asymptote, and I get it from setting the parentheses equal to 0. They have a domain that is affected by the vertical shift, so whatever comes out of that parentheses to positive infinity. And again, these are both impacted by a horizontal shift. Range is all real numbers. And this time you get an x-intercept, which again would come from your t-chart because you're plugging in 0 for y. For the logs, you plug in for y. And again, these, if they're just logs, would be without a calculator. If I ask you to graph ln, then you would use your calculator. Questions on any of that? So all that stuff was still on your quiz. Then 3.3 came condensing and expanding. So you will either have to expand or condense based on what you're given. If I have 1 log times of a product, then I know I'm going to expand it. So this is the same thing as saying log base 3 of A plus log base 3 of B. And vice versa. If I had the right side log base 3 of A plus log base 3 of B, I know I would condense it down into a multiplication. If it's division, it becomes subtraction. So this would be log base 3 of A minus log base 3 of B, and vice versa. If it was subtraction and I wanted to put it together, it would become division. And then the last property we talked about in logs was if it was raised to a power. So if it's raised to a power, that power gets bumped to the front. So this would be B log base 3 of A. And again, it goes both directions. If it's expanded, it means the B's on the front, and you would bump it to the exponent. Those required no calculator. Sometimes when we expand, we simplify. You want to pay attention to stuff like that. The part of this section that would have required the calculator was the change of base. So if I have something that says log of 5, log base 5 of 2, I can rewrite that in terms of the common log, which is log base 10, log of 2 over log of 5, and the natural log, which is ln of 2 over ln of 5. And then if that's on the non-calculator part, you'll actually leave it the way that it is. If it's on the calculator part, then you're going to plug that part into your calculator. And you're going to be careful with your parentheses because you don't want to find the quotient and then find it's 0.431. And you can use both to check, okay? Log of 2 over log of 5 should be the same as ln of 2 over ln of 5. Questions on condensing or anything like that? So a couple of things that like gotcha on the quiz is pay attention to if it's got multiple parts to it. Like, so if it said log of, let's say it was the square root of x, y to the third, over z to the second, m to the fourth, okay? When you separate that out, everything that's in the numerator would be positive and everything that's in the denominator would be negative, which means that this would be log square root of x plus log y to the third minus log z to the second minus log m to the fourth. And then all of those exponents get bumped to the front, but remember that a square root's the same thing as having what as its exponent? A half. So this is really x to the 1/2, which means this becomes 1/2 log of x plus 3 log of y minus 2 log of z minus 4 log of m. And I can put this in any order you want in the reverse. So let's say I gave that question as negative 2 log of z plus 3 log of y plus 1/2 log of x minus 4 log of m. It should get back to that. Maybe the order of the letters on the top and the bottom are switched because that doesn't matter in multiplication. But all those exponents should still line up. So everything that's negative would be in the denominator and everything that's positive would be in the numerator. The 1/2 on the front would get bumped to the exponent and that makes it a square root. So that was probably one of the common mistakes. Just be really careful with that. And then if you can expand and simplify, you need to. So let's say I end up with something that says, here, I'll come over here. Let's say it says this, okay? When I expand that, that becomes log base 3 of 9 plus log base 3 of x squared, and then the squared goes to the front. And I get this. Can that be simplified? Yes, how? This is 2, right? 3 to the what power is 9? That's 2. Sometimes it'll be obvious like that. Sometimes it will be a little less obvious. So what happens when I split this up? I get log base 3 of 18 plus log base 3 of x squared. Log base 3 of 18 plus 2 log 3 of x. Everybody's good so far, yes? 3 cannot be raised to a power to get to 18, right? But is there something I can break that down into that it would? How? 18 is 9 and 2, which means this can become log base 3 of 9 plus log base 3 of 2 plus 2 log base 3 of x. And then this becomes 2. So sometimes you've got to break it down even further because a number could be the product of two numbers in which one can be broken down to simplify. And it's not as obvious. You've got to pay attention to stuff like that. Questions on expansion, condensation, anything like that? Okay, then we added 3, 4, which is what we did yesterday. Okay, the one-to-one property works for both exponential and log. So if I had something like this is what we 2 to the x equals 8, I'm going to rewrite that as 2 to the x equals 2 to the third. Set my exponents equal to each other. With a log, it could be log of x equals log of 3x plus 4. And then the same log is on either side of the equal sign, so I just set the other ones equal to each other. And remember, anything with a log, you'd have to check your answer. Then came exponential, where you are ln'ing both sides of the equation. So if I had e to the x equals a number, or I had e plus or minus something, I have to get e by itself. And then I would ln both sides of the equation. Same thing's going to happen if I got to something like 2 to the x equals 9. I cannot make 9 have a base of 2, right? Which means I'm going to ln both sides of this equation. I'd get ln of 2 to the x equals ln of 9. The x comes forward here, x, ln of 2 equals ln of 9. And then to solve this, I would divide both sides by ln of 2. And I get x equals ln of 9 over ln of 2. And that you can do in your calculator. So if you cannot change the base to be the same, it's an exponential function, and you would ln both sides of the equation.
Do you have to ln both sides, or can you just do like log?
I mean, you can log. Yeah, you can log anything, but on your calculator, you're not going to have log base 2, right?
No. Oh, but like then do the change of base.
Sure. You still have to end up doing the same thing.
Mm-hmm.
Yeah, that's fine. Questions? Okay, then came a single log or ln on one side of the equal sign, and this is where you're going to convert it into exponential. So let's say this said log base 3 of 4. I would convert this to 3 to the 4th equals x and then solve it. Same thing with ln. If it was ln of x, well, let's change that. So that it's ln of 2x equals 10. I would make this e. E comes over, picks up the 10, and then I would solve from there. Both of those you would need to check because they start with a log. And then the last one is multiple logs or ln's where you're condensing and then solving. So this is like the warm-up. If I had ln of x plus ln of x plus 2 equals ln of something, I don't know, 5. I'm not saying that makes sense. And then I would condense this into 1 and then use the one-to-one property. If it was addition, it becomes multiplication. If it's subtraction, it becomes division. And again, those you have to check because they start with an ln or a log. Questions on anything related to 3, 1 through 3, 4? Mary.
Can you go back a little bit?
Yeah. All right, so your test review is on Canvas. The answers are there so that you can work on them over the weekend. Obviously, you want to work through the ones, they should be obvious. Like, get as far as you can without a calculator, and then if it says to round, obviously you're using a calculator. But then ones like your graphs and stuff, try to do them without the calculator because you won't have it. And I would obviously recommend using the calculator you're going to use on Tuesday so that you are comfortable with it.